Hello everybody, welcome to another mini lecture in the Commutative Algebra series. In this one we're going to talk about a neat relationship between ideals in our ring and ideals in the quotient ring, or in a quotient ring. Namely, assume that you have your ring R, and now you take some ideal I in R, and you mod out by this ideal, so you get R mod I, you get the quotient ring R mod I, and from R to R mod I, of course, you have the projection map pi. And if you remember from the previous lecture, if you've watched this, or from your notes, or from wherever you know it, if you remember that while it is not true in general that the image of an ideal is an ideal again, it is true under the additional assumption that the map you're looking at is surjective. And this is the case here. This projection is of course surjective onto this quotient ring. So if you take an ideal here and you apply pi, you get an ideal in the quotient ring. So now let's restrict our attention to ideals, like this one here, J, which contain I. So we speak about ideals J that contain I, and we map them via pi to pi of J. And now this is an ideal by what I've just reminded you of in the quotient ring. So we have a map pi that maps ideals over here to ideals over here. But we also have a map that goes in the other direction and that also maps ideals to ideals. Namely, if you take an ideal here, an ideal here, I've called it here J bar. This is just, the bar is just to indicate that we're now talking about an ideal in the quotient ring. So if you take such an ideal J bar in the quotient ring, and you apply pi inverse, you get pi inverse of J bar, and now you know that the pre-image of an ideal is an ideal. This is true under all circumstances. So this is an ideal, so thus we do get a map that maps ideals to ideals in this direction. And now to establish the one-to-one correspondence, that is the topic for this mini lecture. Well, first of all, I have to tell you between what sets we want to establish this correspondence, or we could also say bijection. This is supposed to be a bijection between the set of ideals, like J, that contain I, and the set of ideals in the quotient ring. So this is what we are trying to prove. There is a bijection between these two sets. And, well, to show that there is a bijection, we just need to show that this pi is a bijection, and for this we need to show that pi of pi inverse of J bar is J again. But this is clear since pi is surjective. And we also need to check that pi inverse of pi of J, so pi of J is an ideal, and the pre-image is an ideal. We need to check that this is J again, so that all in all we get that this is a bijection. But let's just look at it. If we have an element that is in the pre-image of the image of J, then we are talking about an element R in R, which has the property that pi of R is in the image of J. But this means that it is of this form, that it is in this set j plus I, but j plus I, this is just j, because after all, j contains I, and thus j plus I, this is the same as j, and so we do indeed get back j applying these two maps, pi and pi inverse. And this concludes the proof that this is a bijection. And this also concludes this mini lecture. We will use this result on this one-to-one correspondence over in the playlist on algebraic geometry, which as always I invite you to also watch. So for this time, thank you for watching and see you next time.